All right, let's keep moving forward here. All right, now we've been talking a lot about cumulative distribution functions, CDFs. And a CDF allows you to take a value of the random variable, so a value of X, and calculate the area adjacent to that value. Um, and that's kind of going in one direction. Okay. So if we take a value of X, that gives us a boundary. And using normal CDF, we can then calculate the area. Okay. But sometimes you need to start with an area, and from the area, you use an inverse function, an inverse distribution function, and that will then give you the value of X that borders that area. So it goes in the opposite direction. So you need to use the CDF and the inverse functions as kind of like inverses of each other. Okay. So one takes you from a value of X to an area, and the other one takes you from an area back to a value of X. All right. And that's kind of what I put here. Normal CDF converts a value of X into an area next to it. An inverse distribution function or inverse norm converts an area into a value of X bordering it. All right. Um, so let's look at how we use these inverse norm functions with an example. Um, let's see here. Before I proceed, I put note these two calculator functions are used heavily to solve problems, and there are similar calculator functions that will be heavily used for the same purpose. So, we've got a student's T CDF function and an inverse T function. We have a chi-squared CDF function, and I wrote an inverse chi-squared program for the Texas Instruments calculator. There's an F CDF function, and I wrote an inverse F function for the Texas Instruments calculator. Um, those functions come native with numworks, so extra won't be needed there. Okay, let's just take a look here at our first example using an inverse distribution function to go from an area to a value of X. All right, so final exam scores. The final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. Find the 90th percentile. So when I say find the 90th percentile, that is find the score K that has 90% of the scores below that value of K and 10% of the scores above it. So this is in reference to percentiles that we did back in chapter 2. Okay, so all of this may be a little overwhelming. So what do we start with? Always try to start with your given information and draw the distribution. Let's get a visual of what we're working with. All right, so final exam scores in a statistics class. So exam scores were normally distributed with a mean of 63 and a standard deviation of 5. Okay, so we have a mean of 63 and a standard deviation of 5. Now find the 90th percentile. All right, let's draw what we've got first. Let's do that. So we have a normal distribution for final exam scores. with a mean of 63 and a standard deviation of 5, which means we're going to go increments of 5 upwards. And I'll go 3 standard deviations to the right and 3 to the left. So let me go increments of 5 below. Like that. All right. Now, it says find the 90th percentile. So the 90th percentile is going to be some value where 90% of the scores are below it. So what we've got, and I'm just guessing where this is right now, we have some score K such that it is 90% greater than all the scores below it. So this area is equal to 0.90. All right. So let's think a little bit. Can we think about our expectations here? Expectations, well, let's see here. Okay, this is good. So we know that half of this area is 50%, right? So this area is 50%. All right. What is this area here? Well, according to the empirical rule, remember the empirical rule? It's called the 68, 95, 99.7 rule. Well, that's because 68% of the distribution is between +1 and -1 standard deviation around the mean. So 68 is 1 standard deviation above, and I'm talking about half of that. So half of 68. So if I take 68, divide that by 2, I get 34. So this area is 0.34. All right, now this yellow area plus this blue area, this all together gives me a total of 84%, right? So from this mark to the left, that's going to be an area of 0.84. Okay, so I know that my value of K has to be greater than 68. All right, so that's good. Let's see here. What if we went even higher? If I take 95 and divide that by 2, then this area all the way to 73, which is 2 standard deviations over, that area there is, let's see, what's that going to be? 95 divided by 2, 40, 47.5%. So this purple area is 0.475, which means at this point here, this area is going to be 0.5 plus 0.475, which would be 0.975. So actually, my value of K, I need to erase what I've got here. My value of K is going to be somewhere between 68 and 73. All right. So I think my value of K is going to be between 68 and 73. That's what I expect. All right, let's see if it meets our expectations. So let's look at the Texas Instruments calculator um, and the NumWorks calculator. So first I'm going to use the TI-84 plus CE emulator that I've got. If you've got an older calculator, hold on a minute, okay? Because what you see here might be different than what you're going to see, but I'll get to that. Okay, so we want to use inverse norm. So that's going to be in the distributions functions. So second bars. And you can see inverse norm is the third function down. Now here, this is giving me different options. So it wants to know the area. Now the area is that percentile, okay, which was 0.9. So we want an area of 0.9. Here we go. So I'm going to put 0.90. We have a mean of 63, a standard deviation of 5. And what we want is we want the area to the left. Now, what's nice about this inverse norm function on this version of the calculator is it gives us, I made a mistake. This should have been a 0. That would have given me an error. Okay. What's nice about this version of the calculator is that it gives me some prompts, okay, that help me kind of fill in the values. So if I put paste and I hit enter, it's giving me a number of 69.41.